Welcome guys to this new series of videos called Prep for University Test. The goal of this series is to, as its name says, to prepare you for your career admission exam, or if you currently have any doubts about your classes that your teachers are not able to solve for you, maybe here is a place where they will be solved. Also, if you are just a fan of learning, then this is your place. I guarantee you that a lot will be learned over here. Okay, we will start with a relatively quick review of the fundamentals of algebra, starting with the real numbers and their properties. The set of real numbers are all the numbers that we use in our everyday life to describe quantities, measure things, weigh groceries, counting, ordering, among a lot of other things. For example, the number 2 is a real number, just as it is the square root of 2, which its use is not as common in everyday life, but if you're into science, economy, or any career that involves at least some topics with mathematical properties, then at some point you will find yourself with this number. Another example of a real number is a number or constant pi, which I am almost certain that you used it at least once on junior high to calculate the area of a circle. Remember, the area of a circle is pi by the radius squared. We'll see that this real number has a lot of uses other than to calculate the area of a circle. The set of real numbers is represented by the double stroke capital R, and this set is divided into a bunch of subsets which we will talk about right now. Starting with the most basic subset of them all, called the natural number set, which consists of every whole positive number up to infinity, and these numbers are used since the beginning of times to count things or to order things. If we were to count, we use the cardinal representation of the natural numbers. These are 1, 2, 3, 4, up to infinity. If we were to order things, then we would use the ordinal representation of the natural numbers, which would be first, second, third, fourth, up to infinity. That's why they are called ordinal numbers, because they are related with the order of things. The set of natural numbers is represented by the double stroke capital N, and the subset is written as follows. First, we write the braces, or curly brackets, whichever you want to call it, because the braces are a type of brackets. Then we write whole positive numbers up to whichever number you want. Then we write 3 dots, and finally we close the braces. The 3 dots are called ellipsis points and indicates that the pairing continues indefinitely. If we want to include the number 0 into the natural set of numbers, then it would be called the whole number subset, and it would be represented by the following symbols: a double stroke capital W, or the natural number symbol with a subscript or superscript 0. And if we were to strictly specify that the natural set of numbers does not include the 0, then we could represent it with the same capital N and add an asterisk superscript, a plus sign superscript, a 1 subscript, or a greater than sign plus a 0 subscript. All of these variations means the same for now. When we get deeper into the mathematical roots, then we will talk about the subtle yet fundamental differences between them all. But let us not overwhelm ourselves with that for now. Let's continue with our review of the number set. We have just talked about the real number set and the natural number set and their notation. Now we will talk about the integer number set, which basically consists of the whole number set and the negatives. This set is represented by the double stroke capital Z, and the set is written as follows. First the braces, then the ellipsis because the pattern starts from negative infinity, then we write the negative whole numbers, then the 0, then the respective positives, then ellipsis again because the pairing continues up to infinity, and then we close the braces. There are several notations we can use for this set if we want to specify that we are talking about just the non-negative integers. This means that are the positive integers, including the 0. The following notations are the same Z with a plus sign superscript or subscript, a greater than sign superscript, and we can also add a 0 to it, or we can use a greater than to or equal to sign superscript. If we want to specify that we are talking about just the positive, this means that they don't include the 0, then we could use the same Z and a plus sign superscript. And if we want to specify that the integers don't include the 0 at all, then we may write the set as follows. The Z we've been using, and we add an asterisk superscript or a not equal to superscript. Though the one with the asterisk in some cases is used to represent the following set, which means that This integer set just contains the negative and positive one. All of these notations depend on the different authors and teachers you will encounter during your career and professional life, and you will also end inclining yourself towards the notation you like the most. Now, just as a fun fact, don't let this confuse you, but if you notice, we could say this set of integers, the positive one, has the same members as this set of naturals, the non-zero one. And we could say that this set of integers, the non-negative, has the same members as this set of naturals, or the whole numbers, zero included. Okay, enough of integer natural notation. Let's continue with the rational numbers, which may be defined as the numbers that can be expressed as the ratio of an integer to a non-zero integer. It is represented by the double stroke capital Q. For your better understanding, we may write the rational set of numbers as a ratio or quotient between P and Q, where P and Q are members of the integers, but Q cannot take the value of 0. Now, because if it happens, then the result of the quotient will not exist. As we know since primary, if there are apples and we want to share them, it won't be possible if there is no one to whom give them. Much later you will also learn about these drawing operations. Something very important you should know is that every integer is a rational number, but not every rational number is an integer. For example, we have an integer such as 1. We can express it as 3/3, but the rational number 2/3 cannot be expressed as an integer. We can know this by looking at its value in decimal form, that is 0.66 periodic. Talking about numbers in their decimal forms, the rational numbers can be expressed in fractional form or decimal form. If we have 1/3, its decimal form is 0.3333, and we may use a macron or horizontal line to indicate that it is a periodic number, because its decimal expansions number repeat periodically. The ellipsis indicates that it is of infinite length. Another example where we can use a macron is in 125/111, which its value is of 1.126126. You can see that it doesn't have the ellipsis, so it is of finite length. If you see the three figures 1 to 6 repeat, so we use a macron over them and that's all. You may now notice that the macron can be used in periodic numbers of indefinite and definite length, such as we have shown with these two examples. You must take into account that you shouldn't use a lot of symbols just to simplify or specify things. Over the time, you will learn how to wisely use a mathematical notation. As a responsible physicist, mathematician, engineer, or scientist, and being a professional one, you should avoid the abuse of notation. Much later in your career, or right now if you like so, you may look for the ISO 80002. That is the actual international standard for the use of mathematical notation in physical sciences and technology. An example of abuse of notation would be this one, that we have a whole number such as 5, and we add its decimal expansion which are just infinite zeros, and over that we dare to simplify this with a macron over it. It would be ridiculous. Don't do it, please. The next set of numbers is the rational number set, and it is represented with the double stroke capital I. This set is defined as those numbers that cannot be written as a ratio of two integers. This means that no other quotient than divided by 1 will give us the value of our irrational numbers. The four most common irrational numbers are the pi constant, which its value is this one and can be approximated to 3.14. Then there is the Euler's constant, which its value is this one and can be approximated to 2.72. Then we have the square root of 2, which its value is of this one and can be approximated to 1.41. And finally we have phi, which we can call the Fibonacci's number or the golden ratio or many other names. Its value is this one and can be approximated to 1.62. We may discuss this wonderful number much later. The quarterly equal symbol means that the value approximates to, and it should be used mostly when we round numbers. You may notice that the decimal expansion of the irrational numbers is of indefinite length and of non-repeating figures, hence they are not periodic. I should tell you something about rounding numbers. Later in the series, you will learn about the different methods of rounding numbers, such as rounding up, rounding down, rounding to the nearest 10, and several others. There are a lot more of irrational numbers. Other examples would be Euler at pi, and A at B, where A belongs to the algebraic real numbers but cannot take the value of 0 or 1, and B belongs to the non-transcendental irrational numbers. Yes, I know this sounds like a lot of, someone would say, gibberish, but you will learn this in due time. This was just so you could get a glimpse of how big the universe will get when you discover it, and this is just a number. As we said, the irrational numbers are those that cannot be written as a ratio of two integers, because there are not two numbers which their quotient may give us that irrational. We could say they are all unique. Their origins are of the most extraordinary ones, but this is though for another breath. Until now, a lot of information has been given to you. You may have found it easy or not, but trust me when I say that if you are disciplined, focused, and you really like what you are or will be studying, then you won't even notice the enormous quantity of knowledge you will have acquired at the end of these videos. Moreover, the videos will be always there for you to repeat, pause, or swear at them. Be patient, there is a lot of wonderful things to discover. So let's summarize what we have learned today. We have the real number set, that is divided into the irrational and rational sets. At the same time, the rational set is divided into the integer set and into the non-integer fractional decimal expressed numbers, positive and negative. The integers are divided into the non-positive ones, which includes the zero, and into the natural set. If we don't want to include the zero into the non-positive, then the integer set is divided into the negative integers and the whole number set, which we said it can be expressed with the w or the n naught. And finally, the whole number set is divided into the 0 and 1, the prime naturals, and the composite naturals. Let's remember that the prime numbers are those that are divisible just by itself and 1, and the division gives us a natural number, while the composite numbers are divisible by other naturals other than itself and 1 that may also give us a natural number as a result. This diagram may be expressed in mathematical notation as follows. The natural numbers are a subset of the integer numbers. The integers are a subset of rational numbers that are a subset of the real numbers. Yes, this is the symbol to indicate that some set is subset of a bigger one. After a few more videos, you will learn about the complex numbers and those along the imaginary ones, the algebraic numbers, the real algebraic numbers, and the concept of transcendental numbers. All of these will join our little number map over here, and we will be able to discuss which deeper properties each set has. In the next video, we will continue with a review of fundamentals of algebra, and I will explain about the real number line and introduction to inequalities, all types of intervals, absolute value, its properties, distance between 2 points, and algebraic expressions. I hope this video has been useful for you. If you have any doubts, leave them down in the comment section, and with nothing more to add, until the next time, guys.